Hello, this is Max Drake. I want to talk about Python, Bing Chat and astronomy. In fact, it went around the other way. It went from Bing Chat with a bit of astronomy and then on to Python. 35 years ago or something, I did a degree in maths, and it was sort of an aside thing. I never really used it much, but while I was there, I did a part of the degree. I did a course on astronomy, very simple one, first level. But I was intrigued with actually being able to plot the Kepler's orbits of planets, because they're on elliptical things, and actually tracking and looking at their speeds and stuff like that. So I've been tinkering with chatbot GPT and with Bing, and a Bing Chat I've got on my computer now so that I can give that a try. And I suddenly thought I want to try and what I've been doing with it up to date, if you ask it a sort of general question, like how do I make money from making videos or something like that, it gives you normal things, do this, do that, and they're pretty much trite sort of answers and stuff like that. But I found when I was asking it specific things about doing little code snippets and stuff like that, it was very, very good. It gave me a specific answer that was really useful. So I thought, well, my normal method of actually going in and exploring some new field or something that I've got a bit of an interest in is to actually go onto the computer and go and do a browse. And what I actually found was when I'm actually browsing, I tend to get kind of a broad sense of things, but it doesn't go too deep. It tends to be kind of quite light. So where I thought I was going to try to use Bing Chat was to kind of dig deeper. So I suddenly thought, well, I actually want to ask about Kepler's orbit, the formula and things like that. And I actually got the results through here. And then I started to ask questions, how would you do this? What would you do this? Now give me an example of it. So it gave me the formula at the first question and stuff like that. And then it gave you the values of what the things in the values are in the formula, the distance between the moon and the earth, and which ones are actually doing. And then I said, well, what are the actual quantities of those? So it gave me the quantities so that I can just initially just plug in the numbers. So I've got all the little numbers and I can do it from baby steps first of all. Then it comes up with some phrases like perigee and stuff like that, and I started thinking, well, what does that mean? I need to know some of these technical things. So when I'm exploring something new, you end up with this sort of technical jargon. And so you've got to learn some of the jargon and see what it means to get a feel so that you can then ask the right questions. And then you can dig that a little bit deeper and kind of get a bit in. But a lot of times I never quite get a good enough foothold or a good enough confidence in the kind of the basics such that I'm explained to take it further. Or I find there's an awful lot of effort that I've got to do to engage into that level. So after sort of asking these questions and asking some more ones about right ascensions and things like that, you suddenly get these seriously fecking complicated formulas, and I suddenly got a bit intimidated by this. So I said, is there a Python program that can do this, that can get an object in the sky? And he said, yeah, of course there is. And then it pointed me to this thing here called Skyfield. So this is a library that computes the positions of stars, planets and satellites in orbit around the Earth. And then it says it should be to a certain level of accuracy. And then you look at the code and you start thinking, well, that's not hard. I can write that in my little thing and run something. And so I decided to do that. The second one sort of intrigued me even more because it actually has a location on the Earth's surface with a latitude and longitude, and then it gives you it in altitude and azimuth, whereas the first one gives you it in right ascension and declination. So you suddenly, that sounds a bit feckin' jargonistic to me. So this one I suddenly thought, well, this one sort of like maybe is something that I can start with. So I can actually know that I can put my latitude and longitude into here, and then maybe I can go out of my window and look and see if that thing happens. So I said to Bing Chat, can you write me a formula using Skyfield for doing this sort of thing, using that library in Python and stuff like that. So it came up with this thing, and so I got the snippet out of that. So I sort of got distracted in a way. I initially was doing the moon orbit around the thing, and then suddenly I got into calculating the planet locations with Python. And then I got the Skyfield app, and I've got this made to do it. And then I sort of cut it in place. I've tweaked it a little bit and added a couple of things onto it. But I then got that one. So from Willow with that one here, I can then run this one. So if I just run this bit of script through here, I'm actually getting the first one is the altitude and the second one is the azimuth. Now I'll explain those in a second. So I got that sort of information. So in my process, I sort of got into the Skyfield Library and said, okay, then I want a result. So let's just look at the result in there. Now, I've used the sun as the planet that I'm trying to figure out where it is, because I was doing it in the day and I thought I can go out the window and actually look. So it's saying it's 16 degrees, 42 minutes, and it's saying 288 degrees. So that would be the azimuth. So I suddenly thought, well, let's see if I can verify that. We can go into Stellarium. And I've got to go in and put my time. I was playing with that just before. And what am I now? I'm 5 p.m. So 5, 17, 17:07ish. 7527. 8. No, it's not going to let me. So I want to get it exactly just from the point of view of the demonstration. So what I find with Stellarium is it sort of gives me Greenwich Mean Time, and I've got to do this. So we're now at, get down, 0708, we're about there. And now I've got Wellington, which is my location on the map. So I know that this is where the sun is, and I can walk out and I can do that. So let's explain what azimuth and altitude are. Now, altitude, if you look on the horizon, that's altitude 0, and then you look directly up in the sky, directly up from where you are, that's 90 degrees. So the altitude is the altitude from the horizon upwards. The orientation, the azimuth starts at north. So if you've got a compass and you point north, that's azimuth 0, and then you go 90 degrees to east, 180 degrees to south, to 270 to west, and then 360 back to north again. So if I click on the sun on here, and I've got to date my time now, it's saying that the azimuth should be 295, so almost 300, and it should be 23 degrees up. Now, what did I get in my calculation up there? I got 288 degrees and 16. So this is saying 295 and 23, so it's not quite there. So there's a bit of a problem. So when I got this, I suddenly thought, oh, well, the reason why is if we look at the time period through here, so if we just look at the calculation through there, this is using the Skyfield time. Now, when I actually went and looked at the time through there, it gives you this time, and it talks about the Julian calendar, the Julian day. So if we go in, now this is the NASA thing for getting it, and we can go into the Julian day number, and if we paste in that Julian day number, we actually get that is the 26th of the 3rd, 2023, but it's at 4 o'clock in the morning instead of 5 o'clock at night, which is 13 hours later, which is daylight saving. So it's sunny here in New Zealand. 4 o'clock in the morning, it will be dark, pitch dark. So I suddenly thought, oh, well, what I need to do is actually just add 13 hours onto that. But if I add 13 hours onto that, it actually, everything goes dark again. So it's as if it's dark in Greenwich Mean Time. So that doesn't work either. So, but I've got this slight inaccuracy. So suddenly the numbers go mad. They go right out of where they are. So what we've got with this particular equation comes in, it's as accurate as it actually gets. So something didn't quite nest right. So I actually had to suddenly thought, well, okay then. I sort of got the idea of altitude and azimuth, and I can understand where it is. I can match it up. I can match that up with what I actually get. So I can check what I did, and I can also go outside and look at the sun and see roughly where it is in relation to north and the altitude from the sky. And it's sort of in that sort of ballpark area, but not quite there. So I then went back to Bing Chat and I said, is there a different way that you can do it in Python? They said, oh, there's this other library. So instead of using this Skyfield, and I did fluff around with the Skyfield for about 3/4 of an hour trying to get the blooming thing to work, and it wouldn't do it. And it came up with this other one called AstroPy. And I thought, oh, that's good. So I said, okay then, write me a script that will be able to identify where a planet is. So when it wrote the script, and I can sort of use a bit of this earlier on when I come up here, this is my second crack at the thing, it uses this it uses a I don't know how you call them now. Is it a module from a library, or is it a function from the library, or whatever? Anyway, it uses this Skyfield, and it has this method inside of Skyfield where you get the name. And what it does is it goes and looks up this name in an API. And every time I was doing this, I suddenly thought capital Mars, lowercase Mars, or maybe Mars has an astronomical code or something like that. And I couldn't get this to work. And it finally figured out, so this is the standard thing that it actually kept on coming back every time I asked Bing to actually do something on this. And there's this thing called Le Système Solitaire, which actually has an API attached to it that goes through. Now, although it's got all the planets through here, it only returns API information for anything outside the solar system. So it has this example of something like M61 or something, which is something, and it works perfectly. But when you actually try putting any planets or anything like that in, it doesn't work at all. So I then asked Chat. I had a little chat with Chat and said, is there another method that you can do without using the Skyfield does not work? Is there an alternative method inside of AstroPy Library? And it came through with this other one using getBody. So it's got a different function or a different module that it's using to do that. And boom, it works great. We can now use that one. Now that one did do distance. Sorry, I just want to grab that. I don't think I had that in my code. So let's just do that. Put that into there, and we'll just leave that as distance. I've got to rewrite a bit of that to do that. Down. Now let's see that. So I then use this one, and then I said, okay, then let's just use the sun as an object through here, and I can run that through there. And it'll think about it, and it comes through here. Planet. Okay then. Maybe that should be. I might have. See if that works. Playing with this in the middle of the code. No, it's not doing it, so let's just ram that out too, and we'll out to that one. So we'll leave that. We'll worry about that later. It's something I actually do want, so it's sort of saw it there and thought I'll grab it. So on this one here, if we looked at the altitude, it's 22.57 and the azimuth is 294. So if we come back and look inside of the Stellarium and we click on the sun, 294 and 2230-ish. So if we look at that, this is pretty much in the ballpark of where we need to be. 22.57 thing, and I've got 17 of 15, and this is roughly 17 of 15. So I'm definitely got I've got the full degrees there. The minutes maybe I'm a bit out and something like that, but I'm definitely in the more accurate area to do it. So suddenly I feel a lot more engaged with this because I can actually compute something myself. Well, I'm not actually computing myself, but I can verify that what the numbers are coming out. I can do that. So I can start asking myself a whole lot of different questions on this. So suddenly I feel engaged with the process, and to a certain extent I wouldn't have tackled this unless I actually had Bing helping me out with some of the problems and the formulas and things. Now I think it only takes you so far, and it takes you into that simplistic level, but you can actually physically get something done. So a lot of the times what you need to do is to be able to have some code or have something to actually give you a foothold in there that you're motivated enough to engage before. Now I did have Stellarium on my computer for quite a while, and I just sort of, it's quite neat, and I couldn't really see much for it. So the next question, that sorts of things that suddenly get me excited to start asking now is, now if we go to the Willow one, another one that I'm going to use is I'm going to use the example of Mars. I'm actually just reading a sci-fi story about people going to Mars, and they're sort of trying to, no, this one doesn't seem to do it. Oh yes, it does. And they're sort of going to Mars, and they talk about the launch window and things like that. And then you start sort of asking questions. Now, I've never really bothered. I sort of notionally know that somebody can work it out, but I've never felt I was in a position where I could do any of this. So I just want to go into this example through here. Now there's a couple of things that happen through here. You've got the daily rotation, and you can actually go and ask it sort of this. So depending on stuff. Now all the planets are roughly on this plane. So yeah, I think it's called the plane of the ecliptic. So if we actually just look inside here, you see this line here. And so there's Venus highlighting there. If I turn it to night, it might work. There's Jupiter, there's Venus, there's Mercury. They're all just slightly off or just slightly on this plane of the ecliptic, and you can sort of see what else is on there. There's Mars on that one there. So that's this sort of plane where all the planets are actually landing on at this point in time. So if we look at this example here, this is the plane of the ecliptic, because our Earth is tilted 23.5 degrees. So if we just go back to that previous image that I should add onto this one, you see Earth is rotated this. Now, the thing with this is that the Earth rotates the Sun every 365 days. The Mars rotates the Sun every 687 days. So let's just say it's double. So that means for every 2 times the Earth goes round the Sun, Mars has gone once. So there's 2 times within a year when Earth is going to be close to Mars. Now there will be times when Mars is on the other side of the Sun to where the Earth is. So this is one of the things that you can start asking questions like on the results. And this is from the Skyfield one, which is a little less accurate. So now I've got 2 methods. I can suddenly see what I'm doing here, that I'm getting these slightly different things through there, so I can start tracking it down because I now have the code to actually start through. So although I've only got a simple bit of code, I can actually start testing different things out to see where I've got some vagaries or inaccuracies. So one of the things with this does is it says the distance between Mars and Earth, so we've got Earth and the other planet, which is Mars, is 1.39 astronomical units. Now the distance from Earth to the Sun is 1 astronomical unit. Now the distance from Earth to Mars, if they were all in a straight line, is the distance from Mars to the Sun is about 1.5 astronomical units. So if they're all in a straight line, Earth to Mars would be about half an astronomical unit. Now if Mars was on the other side of the Sun, the distance from Earth to Mars would be 2.5 astronomical units. So at this point in time, we know that Mars is 1.39, so 1.4 astronomical units. So therefore, from the point of view of Earth to the Sun, which is 1, if it's 1.34, then it's a little bit past the Sun on one side or the other, depending on which way it actually rotates. So I've never actually even considered asking questions like that. So I was suddenly thinking, well, could I actually calculate, if I suddenly said, okay, then the rocket ship is going to take 88 days or something like that to fly from Earth to Mars, could I calculate what the launch windows are? So where Mars has got to be, so that after something takes off from the Earth and heads out directly from the path from the Earth, a line out from the Sun to the Earth directly out. If they fly along that one, at what point will Mars intercept that 88 days later when the actual rocket ship has got to that point? And I suddenly thought I could do that. So, you know, you see the space films and things like that, and they talk about all of these things, but I've never considered actually being in a position where I could actually calculate those stuff. And then I suddenly thought, well, from a simple sort of a Bing thing for a sort of a notional idea on can I sort of do a Kepler's orbit, and I actually had it was really just a mental exercise that I wanted to try and do to see if I could actually do it. I've now got all of this other astronomy things, and I've had some simple successes such that it's motivating me to learn a lot more. Now, when I was doing it and when I started this, it was basically a morning's work to actually get to this point of starting the questions on the Kepler's orbit, and it take me so far, and then when I asked the Python question, got the code, got one of it running, and it was sort of not accurate enough, and I was suddenly thinking, well, the best thing is, and I got some numbers, and then I thought, well, how do you do a sanity check? So that's when I used Stellarium to actually do a sanity check, and there was a difference in there. And this is one of the things that I'm a bit uncomfortable with. I used to do some heating load calculations for modelling for heating and ventilation in buildings. And I could do the maths, but I didn't have a feel for the numbers. So I used to do all the maths and do all the modelling and stuff like that, and get all the Excel sheets, and I said, there, these ones. Then I used to take it for the boss, because he did them all the time, and he had a feel for that was the sort of right quantity for that sort of a building, or for that sort of a room and stuff like that. And this was the problem. I'd jump into something, I'd do some HVAC, and I'd do some design and documentation and stuff like that. Then I'd go over and do some architecture, then I might do some structure, so I wasn't doing something consistently, so it was familiar enough that you had that sort of gut feel for a sort of a size of it. And this would be a discomfort with me with some of the modelling that I would have done, unless I actually had something like this Stellarium to actually do, is this a sanity check? Is this where it's supposed to be? Are these numbers about right? That I'd have enough confidence to take it further. So I think Bing Chat has got me this way, because to a certain extent, what I would say is that when I started this project, my attitude was I wanted to find and see if I could do some simple maths on something like this. Now I'm actually going to go back and do these Kepler orbits, but the thing is I'm actually going to do a lot more querying to see if I can actually get some Python script somewhere that will actually do those ones for me. And I'd also, I think in my confidence, the way that I'd most probably approach it is to get something like a CAD program and actually reduce the numbers down to scalable things like into meters, or convert from astronomical units into just meters or something like that, to actually plot where things are, to actually get enough confidence that you can start getting a feel for what's actually physically happening. So I can sort of moving into a different area of knowledge of which I don't actually have that much confidence, but of trying to bring it back into an area of knowledge that I do have confidence in, which is drawing and doing that sort of things, such that I can get a gut feel to be able to take it further. Now at this point in time, after half a day of actually playing with this and actually looking at quite a few web things, and I've actually followed it on for another little bit, but I haven't engaged in it that much, I'm still not quite sure with the right ascension on things like that. But I have one tool, which is Python. I've got a couple of different libraries, of which one of them I'm getting quite accurate data from. Now, to a certain extent, on one, I'm getting a distance to these objects, and so therefore I can interpret when Mars or things, so I can move my times forward or backward. At the moment, I've just got the time set to now, so now I can actually add other bits to it, or I can actually add a calendar time or something like that to actually start plotting a whole series of assumptions and things like that to do some things. So I wouldn't have actually thought about doing this. So I'm really pleased with the Bing Chat from the point of view of its movement. It is really I wanted to use it or explore it as a tool for moving into an area of knowledge that I have some skills. I've got some math skills, and I've got a little bit of programming skills and stuff like that. But my astronomy knowledge and the terminology and the things like that, as I said, I did a course 35 years ago, and it's been something that sort of interested me, and you read it in science fiction and things like that, but none of the numbers. So to be able to actually come into a new field with something like this is quite exceptional. So I'm quite happy. And another nice thing is that you're learning in the way that you want to learn. So you're asking the questions, you're getting the results, and sometimes this thing just gets stuck and gives things. You're suddenly thinking, well, it only takes me so far, I've now got to find another method of learning. But to get me that initial foothold into an area of which I don't have knowledge, I'm quite impressed with. So I will be doing some more articles and maybe videos on the astronomy in Python, and I'm not so sure that Bing will be a major part of that. But that's the story so far, and I'm actually impressed with it, because it's got me engaged where just having this doesn't engage me. So I can use my clock forward or something like that to anticipate something. Like at this point in time, I could actually say, well, okay, then at what time will the sun hit the azimuth when it's 0? So is there a way that I can model that so I know what sunset time is? This actually gives you that information there. That's fine. And somebody's actually got all the calculations happening in the background. But I would like to be able to do that myself. And once I do that, I can actually start doing other things with confidence if I get it right, of course.